All right, let's jump right into doing this math skills explanation on rounding. So a rounding review, the instructions say round the given measurement to the specified place value. Specified place value is circled and it just keeps moving. Then determine how many significant figures each number is rounded to. All right, let's start with the first one. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 non-zero values, which means that we have 9 significant figures in this measurement. And what that's telling us is that 8 of them are known for certainty by tick marks, and 1, the 9 at the end, was estimated. Now let's continue, and we're going to change our significant figures as we round here. So our next place value it wants us to round to is the thousandth place. When we round, we take the original number and just fill in up to our place where we will be rounding, and then we consider the number following our rounded spot and ask how does that affect our thousandth place, or whatever specified place value you're working with. If the number is 5 or above, it will round the number up. If it's 4 or below, it will remain the same. So the 9 will bump this 3 up to a 4, and anything past the decimal point, we're not going to fill in a 0. We're going to just drop it because the 0, it's the same value, and we're not going to have that be significant. Remember, zeros after the decimal are significant. So we're just going to drop it as we round so that our significant figures change here. Now we have 8. If we included the 0, it would still be 9. We're going to change the sig figs each time we round. Alright, next we're rounding to the hundredths place. Fill in your values of the previous number. Check the place value, and this one is lower than 5, so it remains the same. Again, drop zeros afterward. Now we have 7 significant figures. Same process for the tenths place. Check how it affects, remains the same. We got 6 significant figures now. Crossing over the decimal point, same process. Check your previous, the 6 bumps, whoops, I got a little hasty there. The 6 bumps the 8 up to a 9 in the ones place. Notice as we move place value, we're getting less and less significant figures. So 2 factors affect how certain a value is. The place value and the number of significant figures can tell you information about its certainty or how good of a measurement it is based on your measuring tool. Now, once we're past the decimal point in terms of like ones, tens, hundreds, thousands, 10,000s place values, we're going to start putting in our zeros as place value holders, because if we don't, if we just try to drop it, it changes the value altogether. So we have to have a placeholder 0. Let's round now for the tens place. Check the previous. That would round our 49 up to 50. And notice, as we round the tens place, our actual significant value is the 5, the 0 is just holding a place value. So now we have 4 significant figures. If we were to try to drop that 0, though, it would change our number from 25,000 to 2,575, and that is a completely different value. So we put the 0 in to keep it consistent. Rounding to the hundreds place. 750, that rounds up to 800. Now we have 3 significant figures. See the pattern here? Our significant figures are going down 1 each time as we round, and we're putting in placeholder zeros when we're working with anything on the left side of that decimal. Rounding for the thousands place, this is going to round 5,800 up to 6,000. 2 significant figures. And lastly, our 10,000s place, the 6 rounds the 2 up to 30,000. And that's 1 significant figure. all of these values should be fairly close in their value, but obviously the one with one significant figure is much less precise or much less certain than our original value with 9 sig figs in the 10,000s place all the way to the 10,000th place. 25,748.6439 is much more specific than 30,000, but they should be around the same ballpark because they are the same value, just rounded for a different certainty. Well, now let's take that same thought process into our examples. This one says round each measurement to 2 significant figures. So we're jumping all the way from the given value and we're going to round it for 2 significant figures. We're going to skip all the other stuff and just do straight to 2 significant figures. So what you'll do to get 2 significant figures is just count 2 non-zero numbers into the original and then round the rest, filling in zeros or dropping zeros past the decimal point. 942. We've got 9 and 4, that's 2 significant figures. That means our number to consider is the tens place. 2 does not bump the 4 up, so we get 940. There's our value rounded for 2 significant figures. You can do that on the rest of these values. Again, count 2 numbers that are significant. I'm going to look at C, we'll do one more together. Remember that these front zeros are placeholders, so those are not part of your first 2 significant figures. It's the 1 and the 5. Then we're going to consider how the 6 affects it. So we're going to have 0.00, not significant, 1, 6. There's our 2 significant figures. The rest fill in as zeros. Okay, you do B, D, and E on your own. Number 2, you're doing the same process, but now for 3 significant figures. So instead of counting for 2, count in for 3. And number 3, round to 1 significant figure. Same process, but instead of counting in for 3 or 2, count in for 1. And then number 4 says go back through problems 1 through 3 and write each rounded value in scientific notation. So let's go back and do the ones we already solved in scientific notation. Remember, we learned about this on Monday. You take the decimal, swoop it over to get a number between 1 and 10. And I moved it twice to get 9.4 times 10 to the second power, if we move it 2 times. Okay. And again, consider, is my standard notation large number or tiny decimal number? It's a large number, so our decimal is positive. Notice that our significant figures match. In standard notation we have 2. In scientific notation we have 2. The times 10 to the second power does not count towards significant figures. That's just its own little notation telling us how large the number is. It's not the significant figures. Kind of like a placeholder. Now let's do the other problem we did together. So move the decimal 1, 2, 3 times 1.6 times 10 to the third. Is it positive or negative? This is a decimal, so it is negative third power. And I'll do that for all of the problems. You can either write your scientific notation right next to the problem like I did, or you can list them all out. Number 4, I don't know if you have enough space down there, but whatever floats your boat. Might be easier for you to just write it next to the problem if you have space. There is today's work.